Hello, good morning, everybody. Yeah, welcome to this class. That's MTH uh, 4, CSC 414, which is our numerical introduction. Numerical analysis. Technically, it's not numerical analysis, actually. It's what's it called again? Okay. Numerical and computational analysis. So to join you in this class, so it's a CSC 414. However, I'm going to mix you up with the chemistry students from 200 level. So they will be doing the MTH 242, but then the two courses are essentially the same. Only that you, computer science students, I may require you to involve some computer stuff in your work. Okay, so what's numerical analysis? What's numerical methods? You may ask. So I'm going to break everything down to you, and I must mention that this course has remained for like 13 years, 14 years now that I've been teaching it. This course has remained my favorite, my all-time favorite. I don't think any other one comes close to it, except maybe coordinate geometry. Yeah, coordinate geometry. But then this is my absolute favorite course. So I want you to enjoy it because you're going to see some really, really interesting stuff in it. So you're welcome. Okay, let it be mentioned that it's an elective course for 400 level. 414 is an elective course, but it's a compulsory course for my chemistry folks, and you're going to see the reason why we continue with this course later. So let's start with the meaning of mathematical methods. All right. Okay. In this program, um, we want to explore some tools that we can use to solve some problems that have that you can't solve with the regular math. Okay. So when we have so regular math, when you use formula to solve problems, when you use quadratic equation to solve problems and stuff like that. Sorry, the formula of quadratic. Those iteration of solving problems. We call those ones analytical. All right, the usual method. The usual method of solving math. Okay, that's the analytical. I can say, let me say, procedures or processes. All right, that's the analytical processes. All right, then there are problems that cannot solve. I will give you an example. Let's quickly look at an instance. Suppose that you have a function f of x equals x raised to power 2 plus 1 x plus say 6 equal to 0, and you are asked to solve this problem. All right. What will come to your mind is that, oh, I can solve this problem using um, completing the square method. I can solve this problem using the factorization method. But let's now assume for a sec that you don't have access to completing the square method. You don't have access to completing the square method. Completing the square. Nope. Okay. What else? What other method do you use? Okay, graph. Yeah, graph is okay. You have access to the graph. You don't have access to the formula. What's the formula called again? Blah 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 blah. I think they call it the almighty formula. The almighty BS. You have no access to that as well. Okay, so you only have access to factorization method. Just factorization. All right, so you have access to the factorization method. So how do you resolve this problem? How do you factorize this problem? So you have x squared plus x plus 6 equal to 0. So you know the usual thing is that you look for two numbers that when you multiply them, it gives you 6. And when you add them, it gives you 1 because this is 1 here. All right, so what do we have? We have, okay, 2 and 3, okay, which will give us 6 when you multiply it, minus 2 minus 3 will give you 60. But when you add, the addition of 2 and 3 will give you 5. The addition of this will give you minus 5. So that's a no-no. Well, you look at 6 and 1, minus 6 and minus 1. Well, they are still not working. Not working. So you are now like, okay, let's look at this stuff again. Can we, is it even going to give us something reasonable? Is it going to give us real root? So let's look at the discriminant. D equals b squared minus 4ac. Well, it doesn't look like it's going to give us a good discriminant, obviously. But then I can fix that. I can fix that. This is going to give us this, because I just picked this out of my head. It's not going to work because it's actually looking like something that is going to give me a complex result, complex plane, because this b squared minus 4ac is going to be negative. It's going to be less than 0. So I may have to suspend this one, and let's see something else that we can use that would help us. Don't forget what I'm doing. I'm just trying to explain to you when we use a where you use a what's it called now? The reason why we need numerical methods. All right, so now I've just found one. Let's look at this one. X squared minus 3x plus 1 equal to 0. Okay, this one looks okay. What will you multiply to give you 1? Okay, let me change the color. Excuse me. So what will you multiply to give you 1? And when you add it, gives you minus 3. Okay, I don't think such thing exists. I don't think so. I don't think so. Now, if that's the case, let's take another approach. Let's look at the discriminant. D in this case is going to be minus 3 squared minus 4, 1, 1, which is definitely, this is going to give us 9 minus 4, which is 5. So it means that this problem has real roots, positive, real roots, two real roots, meaning that it can be solved, only that we don't have the means to solve it. Remember, I said we don't have the almighty formula and we don't have the completing the square method to use. So what are we going to use? So that is where um, numerical methods, that's when it comes in handy. That's when it comes in as a tool. All right. So there are so many problems like this, literally mathematics, that we cannot solve with the usual tools that we are familiar with. You may not be able, there are integrations that you won't be able to use integration for. There are differentiation that you won't be able to use the usual dy dx for. There are several things that there are iteration that you are just giving the table, you don't have a formula, and it asks you to find what is going to happen. What do you think? How do you think they tell you the weather? What formula do you think they are using to tell you the weather? It's nothing but numerical analysis. They look at the variables. They look at today's weather. They look at tomorrow's weather. They look at the day before tomorrow's weather, or the day before yesterday's weather. Then they look at any other variable, and they put these things together in the data, and you know, they tell you precisely what the weather is going to be. That is numerical method. So you can see it's really, really a very, very important tool. So I'm going to have to save this page now and move on to introduction. Okay, so I'm going to save this page. So, okay, introduction. Um, so we are going to be looking in this course. We are going to be looking at course contents. So we are going to be looking at iteration one, iteration two, error propagation, three. I think the third one should be interpolation, interpolation, and the four will be numerical integration. We can call it calculus, calculus. But then in this calculus, we are going to be looking basically calculus. We are going to be looking essentially at integration. All right, so that is it. That is everything, and that's essentially what's. Excuse me. Okay, that's essentially what we're going to be working with. So this morning we'll look at the iteration. All right. So under the iteration, we have four topics. We have the 1 point iteration, 1 point iteration. We have the regular for C. We have the Newton Raphson method. No, shoot, I actually thought that was writing. Okay. Okay, sorry. We have the Newton Raphson. All right. So those are the techniques that we will be looking at. So now let's start with um the 1 point iteration. What's the meaning of iteration? You are actually familiar with iteration. That's when something repeats itself. Um, you base your next your next result is based on your previous results, like an improvement of your previous result. It's like when you are asked to sweep a room. All right, or okay, iteration is technically, let's say you wash your clothes manually and you want to rinse it. You pass it through the water the first time. You still have some, the water look kind of brackish, maybe soapy, kind of. Then you don't feel comfortable with it because this is like a very expensive cloth, and you wouldn't want it to have chemicals in it. So you run it through water again and again and again until the water becomes so clean that you would be tempted to drink it. Then at that point, you know that you have come out with your finest result, and that's essentially what iteration is. So that is what we want to do now. So the process of iteration is really, really simple, and we are going to look at it. At least in today's topic, that's how we will be looking at iteration. I mean, sorry, 1 point iteration. That's what we're going to be looking at. So now we'll talk about some things. We want to find the root of so let's look at roots of an equation. So we want to look at the root of an equation. What is the root of an equation? That is every equation we believe can be charted. What I mean by that is that you can draw the graph for every equation. This is the y-axis, this is the x-axis. And now that's the function f of x. All right, that's the function. This is the origin. Now there's a point here. where it crosses the x-axis. So this point, we call this one the root of the function f of x. What does it mean? It means that at this point, the value at this point has a value of what? 0 on the y-axis. That is the point where the function dies, or have the value 0. That is called the root of an equation. When you plot it on the graph, that's the point where the curve crosses the x-axis. Okay, that's the point where it crosses the x-axis. So I'm saving again. All right. So when we have that, when we have that definition, let's see what else we can talk about based on that definition. So if I have a function equal to 0, it means they're asking me to find x that will turn this whole thing to 0. Okay, that's what they're asking me to find. Okay, so for instance, if I have f of x to be 3x plus 2, and they ask me to find the root, that would be 3x plus 2 equal to 0, which implies that 3x equals minus 2, and your x will be nothing but minus 2 over 3. So minus 2 over 3 is the root of the equation. That is, when you take this one and insert it where x is there, this value becomes 0. All right, that's the root of an equation. That is essentially what we are always looking for when we are doing when we are solving algebra. I mean, in algebra. Okay, now what in iteration? In iteration, what you do is that you have the function f of x. Okay, so let me now say one point iteration now has a topic. So we have a function f of x. They are asking us to find a root. That is, we are asking us to find uh, uh, when it's equal to 0. So what you do is that you create a g of x. All right, you create a g of x, and equate it to x. Okay, well, that doesn't make sense now. It never really made sense to me when I first encountered it, because what we are saying is that we should make x the formula, of a function that still contains x in it. That doesn't make any sense, but then just stay with me and then you see the reason why it is so. Now, when you do that, then that becomes your iterative um, um, algorithm, so to speak. So you can now say x naught, which is the first one, will now be gx. Okay, sorry, x 1 will now be gx naught. All right. So here, let me put this one as naught. Okay. So then x2 will now be gx2. All right. Don't worry. Don't worry. If you don't understand what I'm doing yet, you will. X3 is going to be gx1. X3 will be gx2. I need to continue like that until you get to x n, which is going to be gxn minus 1. Okay. So I think the convenience at this juncture, we can just pick one of the examples and solve it. So let's look at that one that we picked earlier, the one we picked earlier in the topic, which is um, example now. In this example, we have estimate the root of x squared minus 3x plus 1 equal to 0 using the 1 point iteration technique. Okay, we should use the 1 point iteration technique. So let me save this page because I'm going to send it to you later as my scrapbook. So, all right. Okay, fantastic. So now, don't forget what I said. I said you are going to make x the subject of the formula that still contains x. All right. So we have x squared, right, minus 3x plus 1 equal to 0. Okay, this is actually, let me say equal to f of x. This is our function. This is the function we want to deal with. Okay. Now, how many ways can you make x the subject of this formula? Let's look at it. All right, in a very crude form now, in a very, very crude form, in a linear form. So we can say, well, x equals, okay, so this is, okay, all right, let's do it. Let me clear the screen. Let me start all over, sorry. Okay, so now we are going to have, so we have our function of f of x to be x squared minus 3x plus 1 equal to 0. That's a that's a problem we are asked to solve. Now, um, we now want to make we want to make x the subject of this formula. How do we do that? All right. So let's look at this. We can say x in a linear way, not in the real sense of it. We can say x equals minus 1, can't we? um, minus 1 minus x squared over 3. We can say that. What I did is that I moved this 1 over, then I moved this x squared over. Okay, this is going to be minus 3, of course. All right. Okay, and then to simplify it further, we know that it's going to be actually 1 minus x squared everything, plus x squared everything over 3. Okay, that's what it's going to be. That's the first one. The second one is that why don't we consider the square? All right, or x. If we are considering the square, it means that we are looking at x equals. Okay, let me start with x squared. X squared equals minus 1 minus 3x, which means that x itself becoming the subject of formula will be minus 1 minus 3x. That's another one. And the third one is that why don't we even go crazier and say her, still based on this, her x squared over x equals minus 1 minus 3x over x. So we now have x equals minus 1 plus 3x over x. You know, we can have that as well. Those are the three. So when we look at these three, we need to pick one of them as our gx. Hope you understand what we're saying. You know, I said earlier that we need to create a gx. Now, and this gx, what it does is that we will be putting values for the hexes. Let me pick a different color just to excite things a little. Okay. Yeah, this is my favorite color actually. Yeah, navy blue. Yeah. So let's see how we think we can do this. We can actually, okay, now we have to be putting values where the hexes are. All right. So if we put this one looks cool, whatever value you put here, you won't run into trouble. But look at this one. Look at this dude. If you put some silly ass hex here, then you may have a negative value. And then you are dealing with square root of a negative value. And that would definitely be from the complex root. You don't want that. I don't want that. I don't want that at all. All right. So now let's come here. What if at a point you need to put 0 there as the value of x? Then you have a denominator that is 0. Then this one will become an infinity, which is not a number actually. So you don't like that. So you should try as much as possible to avoid the square roots, and you avoid having a variable as your denominator. So that's why I think this one is by far the best option for us. So we have found our g hex to be equal to 1 plus x squared over 3. So that is our iterative function. And now, how do we now start? You look at the formula. So we need to get an x naught, which is like our initial value. Okay, x naught is the initial value. Yeah, this initial value. How do we do with this initial value? How do we get it? So look at the formula again. The formula, I mean, the problem you have is x squared minus 3x plus 1 equal to 0. So what value can you put here in this formula that will move you close enough to 0? All right. So I think if x equals 0, then we are going to have 1. Well, 1 is not far, which is not far. Curve from 0. All right. So let's pick our x naught to be. Therefore, we select x naught to be 0. Okay. So don't forget we now have this as our initial, I mean our iterative function. We now have decided on this as our initial point, initial takeoff point. Okay, so now I'm saving this. Okay, so I want my scrapbook to be as fanciful as possible, so I'm going for another color. Bite me if you don't like it. Okay, I'm going for green. Sure, green. Okay. Okay, fantastic, green. Okay, I have something there that is not covering up now. It's covered. So, okay, so we have green and the whole. So, so we have, like I said earlier, we now have x equals 1 over 3 into 1 plus x. Okay, So, and then we have x naught to be equal to 0. So, if x naught is equal to 0, then our iteration is going to be like x1 equals 1 over 3 into 1 plus x naught, which is going to be 1 over 3 of 1 plus 0, which is going to be 0 0.333. So I always leave it at 4 dp. Actually, this green look hideous, but then we are stuck with it. All right. So now you have found x1. Let's find x2. Let's find x2. X2 is going to be 1 over 3 into 1 plus x1, which is going to be what now? 1 over 3 into 1 plus 0.3333. And this is going to give us 0.7, okay, sorry, 0.3704. Okay, which is cool, which is kind of cool. All right, so we have found x2. Now you will be asking me, this is a natural probe, this is a natural question. You'll be asking me, when is this stuff going to end? When are we going to stop? You will see when we're going to stop. You see when we're going to stop. It's so delightful. Uh, I don't wanna let the cat out of the bag now, because I want you to see it. I want you to feel it yourself. So now let's look at x3. It's going to be 1 over 3 into 1 plus x2, which is going to be 1 over 3 into 1 plus 3.7, oh sorry, 0.3704. Okay, that's x2, that's x3, and it's going to give us 0.37, I think 91. Okay, 0.3791. Okay, please help me to check it. I think there's a typo in my work here. Now, x4 is now going to be 1 over 3 into 1 plus x3, which is going to be 1 over 3 into 1 plus 0.3791. And your answer is going to be 0.381812. Then your x5 is going to be 1 over 3 into 1 plus x4, which is going to be 1 over 3 into 1 plus 0.3812, and it's going to give you 0.3818. Okay, then your x6 is going to give you 1 over 3 into 1 plus 0.3818, and that is going to give you 0.3819. That's going to give you 0.3819. All right, so I'm gonna have to pause at this point to save it. Now we're at x6. We need a few more. So let's look at x. Let's look at x7. Let's look at x7. Okay, so now x7 is going to be 1 over 3 into 1 plus, of course, x6, which is going to be 1 over 3 into 1 plus, plus 3819. Now, at this point, you are going to have, that's 0.3819. You are going to have, let me, okay, you are going to have 0.3819 back right at you. Okay, so what have you come to? You know, if you run this again, definitely you are going to get that value again. So you can say that you have reached what we call convergence. All right, now clearly x8, x9, and so on will continue to yield 0.3819. Okay, which we gladly call convergence. Now let's test it. So this is what the scheme is telling us the root is going to be. That is, therefore, the root, the approximate root, approximate root of f of x equals x squared minus 3x plus 1 equals 0 is 0.3819. Now let's test it. Okay, let's see how far off from 0 we are. So all you have to do now is to put 0.3819 into the function. You square it, minus 3 times 0.3819 plus 1. What is this going to yield? What is this going to yield? I'm going to use my calculator. I think I'm going to use hyper calculator. Hyper. Yeah. Just wait for it. Let's see what it looks like. Later. Okay, let me clear this count. And we are going to have 0.3819 squared, all right, plus, sorry, minus, it's a minus, minus, okay, sorry, minus 3 times 0.3819. Then you close it. See what you have. We have 0.9999. Okay. Yeah. So, but that is the best we can do with this. And then I have a story to tell about that. Okay. So we have reached the convergence. Okay. So it's minus 0.999. Blah blah blah. Okay. Okay. Let's put another line since we have been using. All right. So that is, we have now tested it, and we have seen that at least we have achieved something that is not bad at all. Okay. Whoops. I think I made a mistake. Sorry. I have to go back. Let me go back to that. Okay. Okay. I think I have seen my mistake. I was actually wondering what was going on. So I still have to add 1 plus 1. Okay. So we now have 0.0014. So it's now going to be, it's actually not this, it's actually 0.00014, which is very, very, very significantly close to 0. It is significantly close to 0. So that is it. So something, so we know now that this is going to be the root of the equation. Now it's a quadratic equation. All right, it's a quadratic equation. Let me save this page and do some talk. It's a quadratic equation. Oh, oops. What did I do? Okay. It's a quadratic equation. All right. So you would expect, I don't have to, because the class is practically over. Since it's quadratic, you would expect something like this. All right. You expect a root here and a root here. So you would expect two roots equation. You can't even find one normally. So you are even lucky to have this technique to find one. So if you are looking for the second one, it means you have to select a different x naught. If you are selecting your x naught to be 0, then you are going to get 0.3819. But then you can select your x to be something else. It may, instead of it coming this direction, seeking this point, it may be looking at that point. That's the way it is. All right, so that's a technique. There are other techniques. I just checked my note now and I saw that there is this bisection method. Instead of three, initially I said we have a one point iteration. Okay, so now obviously we have a bisection method. Then after bisection method, we'll look at another technique called regular force method. And then we'll look at the father of it all, which is the Newton-Raphson. Okay, which is the Newton-Raphson's technique. All right, so let me give you a brief assignment. All right, using the 1 point iteration. Technique. All right, find the root of x squared minus 4x plus 2 equal to 0. Let's find that. Find the value of x when x squared minus 4x plus 2 equal to 0. Let's say this is 1. Number two, watch this video and create a sexy note out of it. All right, thank you very much. I'm signing out. Today is the 11th of March 2024. Thank you very much.